Hello everyone. So today is gonna be our day 32 of the DSA challenge, right? So continuing the list, we are on the question called detect a cycle in a single linked list, right? Given the question says that given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is sorry used to donate the index of the node the tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false, right? Okay. How can we do this question, right? Before that, let's understand what a cycle is. Okay, I'm gonna draw something out for you, and then we'll understand, right? Okay, so this is a node, this is another node, another node, and this node is connected to this. So there are four nodes. Let's just say one, two, three, and four. These are the values. Okay, and probably let's just say head is given to you. This. Okay. If I say head dot next, you will reach to head comes here. Okay. So head is given as 1 initially. Head dot next is 2. Now head brings where it becomes 2, right? Head dot next becomes 3, right? Head also becomes 3 now. So head dot next becomes 4. As soon as we turn to head dot next, head becomes 4. Okay, cool. Sorry. Then as soon as head dot next, now head dot next is 1. Okay. So you notice as soon as I move to head dot next, it becomes 1 again, right? As soon as I traverse this head now comes here, then head comes here, right? Then as soon as head goes back here, we reached 1 again. So if you notice, 1 was there, right? And this loops keep on going, right? If you notice, this loop keeps on going every time. So it is an infinite loop kind of a thing, right? Infinite loop kind of a thing. Okay. Do you think that ever we will have a null pointer here? No, right? No, we will never have a null, right? The reason is that null is something that terminates a list. Terminates a list. But do you think this list is terminating? No, this is not. This is an infinite thing. And this is what a cycle is, all right? So cycle can be made up of a lot, two or more, not two, at least three or more nodes. This is something that a cycle consists of. Okay. So let's copy this and let's understand how can we solve this question. Okay. Cool. So given 3, 2, 0, 4, and then this 4 minus, sorry, 3 to minus 4. Minus 4 is again connected to 2. So it is a cycle. It is a cycle, right? You can see in the pictograph that it is a cycle. Okay. But how can we, think of it? Okay. Let's just say I am given head here, right? And I initialize temp. Hmm? Temp, like we always do. We do not ever tamper our head. We always use a temporary temporary node to traverse. Okay. Temporary pointer, not node, temporary pointer. Cool. I am at 3. Then I come to 2. Then I come to 4, minus 4. Sorry, 0. Then I move to minus 4. And then again I move to 2. I know that I have been to this thing, but what is the proof that I've been here? Can you notice? Can you figure out now? We have been using a concept of hashing, right? Hashing, which is used to store, something. What is hashing? What is caching and hashing? It is something to store that yes, we have been to this node, to this element before. We have been here, right? It can store anything, anything. You can obviously use map, set, right? But see, what does map store? Map store two values. One, you know, two values, v, two values, right? Okay. Now, if it stores two values, I can obviously say that, hey, first value can be node and other can be visited. This visited can be a boolean or can be 0/1, whatever you want to say, or not 0/1, one or more, right? If you have visited, mark it as one. If you again visit, mark it as two, and so on. But here, if you notice, we only need to return true and false. We don't need to return anything else, right? So why will I even use map, right? I can use a set. What does this save? Unique values, right? Unique values. What is the correct way to store a set? Basically, a value in set. Is it the node dot value? This is the question. Okay. Three. Again a three. Okay. Let's just not make it zero. Again a three. If I store something in a set, I will say that, hey, three was here, right? Temporary is here. As soon as I move to this will say that, hey, 3 was again here, so 3 will not be saved and you will return true. Though the answer is true, but is this the point where we need to understand that, hey, okay, let's just say this is not here. This is this is what it is now. The list is this. Is this should the answer be true? But from your algorithm, the answer will be true. So instead, we store node. And in yesterday's video, I explained to you what is a node and what is basically what a node is. It's an object, right? I told you yesterday, object of a class, object of basically object of list node, right? Okay, cool. So if I paste it again, I take a set here, right? And my temporary variable is also here, head is also here. Three, right? Node three. Cool. Node 3 has been saved. Temporary variable goes to here. Node of 2 saved. Okay, cool. Node of 0 saved. T comes here. T again comes here. Of -4 also saved. Is there any value that is repeating? No, right? But as soon as I move my temp back to this point, you will notice that this already exists. This already exists in the set. And then you will return true, right? Very easy. You don't even need to know the pseudocode since we have been doing this for a long time now. What is the time complexity? At least O of n. Why O of n? Because we are traversing the whole list at least once. As soon as we, you know, point to a different, or I can say that this n is the length of the nodes before the cycle plus the cycle. Hmm. I mean, after it doesn't matter because there won't be any node after the cycle, right? So this whole means n only, all the nodes. Space complexity, again O of n, we are saving all the numbers. The interviewer might say that, hey, I don't need you to use an extra space. Okay. Then what else can we do? What else can we do? Let's see. I'll tell you something. We have already, this is head, okay? This is head. I have already told you one. very famous approach called slow fast pointer approach, or tortoise hare approach, or rabbit turtle approach, or whatever you want to call it. uh, Floyd cycle approach, Floyd cycle algorithm, right? Cool. Can we use that? Let's see. Let's see. Okay. 3, 2, 0, -4. This again connected to this. Let slow be here and fast also here. Okay. Let slow be here and fast here. Let's see first that if this app is this approach applicable. If yes, then we'll later on see that why is it applicable. Okay. Why is it applicable? Cool. Slow comes here, fast comes here. Slow comes here, fast again comes here. Cool. Slow comes here, fast also comes here. Do you notice something? Do you notice something? That slow is equal to fast. That means there is a cycle. That means there is a cycle because both of them are colliding. If slow is moving by 1 point, fast is moving by 2 points. And if no cycle or no cycle, then slow and fast should never meet. Should never meet, right? They should never meet because it's a straight line kind of a thing. If like yesterday I explained to you something, right? If slow is traveling with x speed, right? X meter per second or kilometer per hour, whatever. Fast is traveling 2x meter per second. If it's a straight line, do you think slow and fast will ever meet? Do you think they will ever meet? No. But if it's a cycle, if it's a cycle, if it's a circular kind of a thing, if it's a circular track, I yesterday explained to you this thing. In physics also, you must have read about it, that if slow and fast starts at a certain point, there is there will be a point in that circular path again, that they will meet. Obviously, we'll have to calculate how will they meet. I'm not going to go into the physics of it, but they will meet. Okay. So let's first understand why will they ever meet? Why will they ever meet? Okay. Is there any other better example? No, there is not, right? There is not. Okay. What can I do? Okay. Let's just say this is something, not even this. This is something, one node, one node, 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 another node, and another node. 1, 2, 3, 4, 5, 6, 7. 7 nodes. Cool. Okay. I start from here. I start from here. And not even, let's just say my slow pointer is somewhere here and my fast pointer is somewhere here, right? Randomly I'm putting it. Randomly I'm putting it. Okay. What is the difference between them? 1, 2, 3, 4. Let's just say slow is 4 points ahead of fast. 4 points ahead of fast. Okay. Let's traverse. Slow comes here, fast comes here. Let's now notice how many points are there. 1, 2, 3. Okay. Slow is 3 points ahead. Cool. Again, let's move. Slow comes here, fast goes here. How many points? 1 and 2. 2 points ahead, right? 2 points ahead. Okay. Slow moves here, fast moves to this point. How many points ahead? 1 point ahead. Slow is 1 point ahead. Okay. Slow moves here, fast also moves here. Fast also moves here. So slow is 0 points ahead. Can you notice something? First, it was 4 points ahead at a certain point. Then it became 3 points ahead. Then it became two. Then it became one. Then it became zero. That means that if the distance is d, right? For every traversal, for every traversal, d becomes d minus 1, right? D might becomes minus 1, and this will someday be equal to 0. Someday, right? Someday. If D is equal to 100, it takes 99, then 98 steps ahead, then dot, 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 0 steps ahead. And this will be the point where they will meet. And this is something to be noticed of, that any any iteration D will always be divisible by 1, for sure. For sure. That is why slow and fast pointer is the correct approach. Is the correct approach. What is the time complexity? Almost O of n. Maybe they will meet at a certain point. Maybe they will traverse few nodes extra. But in the worst, I mean, in what do you call? In the far side, we can always say that O of n, right? Space complexity. Are we using any extra space? Why is it space complexity? No extra space? Can you see the follow-up question? Can you solve it in constant memory? Didn't we do that? Didn't we do that? But, but I am telling you one thing. The question is, if you have to return Boolean value, that is true, false, that hey, cycle exists or not, then the slow and fast pointer is a good approach, because obviously you will know that hey, they are meeting at some point. But if if you have to tell that what is the starting point of it, what is the starting, like for example, 2 is the starting point, 2 is the first meeting point again, because if you notice it is connected to 3 point, basically 2 pointers, one is here and one is here. Then that in that case we will have to use a set, because we'll have to keep a track, right? Whichever is the first one that is repeating, whichever is the first node that is repeating. So according to the question, you will have to change your approach, right? Okay. Now that we have done it, let's just simply write the code. Let Very easy code. Let slow is equals to head. Oh, one more thing. Sorry, one more thing I have to explain to you, right? Okay. I have 1, 2, 3, 4, 5. 5 nodes. And I have 1, 2. Can I copy it? So there are one, two, three, four, five, and this is list one, and list two contains one, two, three, four, five, six, five, six. One list has odd number of nodes, and list two has even number of nodes. Let's just see something, okay? Let's just see something. My slow pointer is here, F pointer is here, okay? Which is the pointer that will be moving faster? The fast one. That means fast will always reach null, and assume, see, this list has nothing to do with, you know, nothing to do with cyclic approach. It has nothing to do with cyclic approach. But why is it important? I tell you later on. Just bear with me. Fast will always reach null first, because if it is traveling faster in a straight line, obviously it will reach first. Okay. So fast goes 2 points. It runs to this point. Next point, it reaches to null, right? It reaches to null. Cool. Okay. And my slow fast pointer is here. Again, in an even situation as well, fast will always reach first. Fast goes here, then fast goes here, right? Uh, so am I traveling correct? So this is correct. This is correct. Oh, sorry. Fast is not here. Fast comes here, right? Fast comes here. And now fast comes to null. If you notice, in odd, fast dot next equals null. In even situation, fast becomes equal to null. Fast becomes equal to null. So now comes the point which I was talking about. We have to write our situation in such a way that my while my fast is not equal to null, and and my fast dot next is also not equal to null, right? Right. Both of the situations have to match, because I don't know which of the list is it. Is it an even list? Is it an odd list? And even if the cycle exists or not, right? I am considering it to be a straight line forever. I am considering it to be a straight line forever. This is my assumption that, hey, the list is not cyclic. The list is not cyclic. That is why this situation is important. So remember this, right? Let's now write the code. Slow is pointing to head. Fast is also pointing to head. Cool. While situation that we discussed, fast is not equal to null, and fast dot next is also not equal to null. I will say slow is equals to slow dot next. Fast, you remove 2 points. So fast dot next. If slow is equal to fast, return true, or else at the end return false. That means if any of the situation, any of the situation matches, right? If any of the situation matches, this loop will be out. This loop will be out. So return false. Let's try to run this. Accepted. Let's submit it. Accepted, right? Accepted. So I hope this question was definitely easy for you, because see, this question at the end is very easy. Traditional, slow, fast pointer approach. The question is definitely easy, but the approach is used many questions, right? So that is why this question is the building block of other questions. So yeah, I hope this question was you were able to understand this question. I'll see you tomorrow with a question called reverse a linked list in groups of k, in groups of size k. If you remember, we already did a question, reverse a linked list, that is completely reverse the list. But here we are going to reverse in k blocks, right? Some part of that some part of that list. Okay. So yeah, thank you so much, guys. I'll see you tomorrow. Bye bye.